Hello everyone. In this video, I will guide you how to solve the equation about application of standing wave. There is a few questions in this video, so please stay tuned. Alright, the first question. A fundamental tone of a sound has a frequency 1 MHz. Determine the frequency of third overtone for odd harmonic axis. Let's find the keyword here. The first keyword, fundamental tone, frequency 1 MHz, means that 1 MHz. Determine the frequency of third overtone for odd harmonic axis. So keyword yang pertama, dia kata ada fundamental tone frequency 1 MHz. Fundamental tone normally we write as F1, which is equals to 1 MHz. Same as 1 multiplied by 10 power of 6 Hz. Determine the frequency of the third overtone. So we need to find F for the third overtone for odd harmonic axis. Remember that again in the previous lesson, for the odd harmonic axis, it is for case a closed pipe. For a closed pipe, the number of the harmonic, which is n, number of harmonic kita akan denote by n sama dengan 1, 3, 5, 7. Is it odd, isn't it? Dia adalah nombor ganjil. So untuk closed pipe, number of harmonic dia adalah nombor ganjil 1, 3, 5, 7. But not first harmonic is the first overtone, second harmonic second overtone. Bukan. So kita kena figure out lah. Let's see clearly and carefully. The first harmonic, for sure we call it as the fundamental frequency. After fundamental frequency, we do have first overtone. Selepas tu kita ada second overtone. Selepas second overtone, kita ada third overtone, and so on. So the first harmonic n equals to 1 here refer to the fundamental frequency. The first overtone is referred to the third harmonic. The second overtone refer to the fifth harmonic, and the third overtone is referred to the seventh harmonic. Alright, so here is the solution how to do it to figure out the frequency. So we do have equation Fn equals to n multiplied by the fundamental of the frequency, n which is number of harmonic. So third overtone, third overtone, jangan ambil 3, n sama dengan 3, but for the odd harmonic, third overtone adalah 7 harmonic. So kita akan ganti 7 dekat depan ni, 7 darab dengan dia punya fundamental frequency tadi, then you get the answer. Alright, the next one. When a student slowly blows across open top end of a test tube. So means that this one adalah closed pipe. A sound note of the fundamental frequency is produced if the student blows harder. The subsequent frequency of the sound note will be, how many harmonics number? Alright, so the keyword is here. Kita ada closed pipe. So closed pipe, again, the number of the harmonic will be odd number, isn't it? 1, 3, 5, 7, blah 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 blah. So if you the first note yang kita dengar adalah fundamental, so subsequent maksudnya selepas tu, selepas fundamental adalah 3 harmonic, 5 harmonic, and so on. So the answer is D. The next question. The tension in a taut rope is increased 4 times. Kita ada tension increase 4 times. How does the speed of the wave pulse on the rope change? So dia tanya perubahan velocity terhadap tension. So what is the relationship between tension and velocity? We do have one equation that relate both. Velocity is equals to surd of the tension divided by mu. What is mu? Remember that again, mu is the mass per unit length. Alright, now the question asks you about velocity and tension, the relationship between velocity and tension. So here is the relationship between them. V is directly proportional to the square root of the T, isn't it? So kalau tension to increase 4 times, kita akan masukkan 4 dekat sini lah. Okay, 4 kali ganda tension. Alright, so the new V, let's say V new, akan sama dengan 4T. This one kalau kita cerakinkan, set over 4 is 2. So set V new equals to 2 set T. So here set T tadi adalah V, isn't it? So ni tadi, yang ni lah. So V new adalah 2 kali ganda daripada V yang asal. The next one, an organ pipe of length. So kita ada length of an organ pipe open at one end and close at the other end. Okay, so ni maksudnya satu terbuka, satu tutup. So dia merujuk kepada closed pipe. So this is the length of the pipe. Calculate the frequency of the fundamental note N. Okay, ada 2 soalan N first overtone. Okay, let's see. So cari F1 sama dengan apa? First overtone untuk close pipe. Okay, kita buat close pipe. Close pipe, number of harmonic 1, 3, 5, 7 and so on. Okay, kita dah tengok tadi, this one is fundamental. So F1 ini first overtone. So later on, bila you nak cari berapakah nilai first overtone, so kita boleh guna equation Fn equals to N Fn F1. So N kita sebab first overtone untuk close pipe adalah 3 harmonik, so kita akan gantikan 3 kat sini, 3 kali dengan first overtone punya nilai frekuensi. But first, di soalan ni suruh cari dulu frequency of the fundamental note, which is the first harmonic number. Okay, so how to find the fundamental? Okay, this is the closed pipe. Fundamental means that the basic wave of sound. So if you look like this, so this length is referred to the lambda divided by 4. So lambda will be equals to 4L by using equation V, speed of wave, V equals to F lambda. Kita nak cari frekuensi, so V bahagi dengan lambda. V ni sebab kita guna pipe, so V ni adalah daripada speed of sound, which is given 331 in the equation. So 331 bahagi dengan lambda, which is here 4L. So substitute the value, the length is 33 cm. Remember that to change it to the unit of the meter, then you will get the answer. So that one for part A. Okay, and then use that frequency to find the first overtone. Okay, what about question B? Okay, question B, length of pipe at open at both end. Right, open at both end right now, having fundamental frequency that is equal to the difference between the two frequencies calculated in one. Okay, so read carefully. Just cari length of pipe at both end. Okay, so sekarang kita ada pipe yang terbuka dekat dua-dua. So kita cari length dia sama dengan berapa. Having fundamental frequency, so that fundamental, its fundamental frequency equal to the difference between the two frequencies calculated in one. Okay, so fundamental frequency untuk soalan B adalah sama dengan perubahan. Dua frekuensi yang kira dekat atas. So tadi kat atas kita dapat 753 dengan 251. So tolak lah 753 tolak 251. Modulus dapat berapa nilai frekuensi you all. Okay, so then you akan dapat the values of the frequency here. Okay, kalau untuk open pipe fundamental frequency maksudnya the basic wave lah untuk open pipe. Okay, since open pipe, so sini mesti anti-node, sini pun mesti anti-node. So the pattern will be look like this. Okay, so panjang ni this L is equal to, ada berapa quadrant? 1 quadrant, 2 quadrant. So lambda over 2. Okay, L equal to lambda over 2. L equals to lambda over 2. So lambda equals to 2L by using velocity of wave. V equals to F lambda. This one is the speed of sound. Okay, sebab ni adalah pipe. So 331 equals to frequency yang kita nak cari. And then lambda sama dengan 2 kali L. Frekuensi kita nak cari pula. Frekuensi ni you all dah dapat dah daripada atas ni. Okay, so L yang you all nak cari. Then dapatlah jawapan. Itu saja. Thank you.